So our focus this unit is on quadrilateral. We've already learned a lot about quadrilaterals. We have learned that they are four-sided figures, that the interior angle sum is 360 degrees, and we got that by taking our number of sides, subtracting 2 and multiplying it by 180, and that their exterior sum is also 360 degrees because all polygons, no matter how many sides, exterior sum is 360. We have also focused a lot on parallelograms. That's what all of last week was all the characteristics of parallelograms. This week, we're going to focus on the rest of the types of quadrilaterals that are listed here: rectangles, squares, rhombus or rhombi, trapezoids, and kites. Today's is going to be over rectangles, squares, and rhombi. So we're going to cover 3 more quadrilaterals. As a review, parallelograms, because it's going to be important to today's lessons. Opposite sides are congruent to one another. Opposite sides are also parallel to one another. Opposite angles are congruent. Consecutive angles are supplementary, which means if this was 80 degrees, its consecutive angle, or the angle right beside it, would be 100 degrees. And finally, the diagonals bisect, meaning that when the two diagonals cross one another, they essentially form a midpoint, and the diagonals then become bisected, or they're of equal lengths. If you have not taken a picture of this slide yet, I urge you to take a picture because you can use all this information and notes on your future test, which is already going to be next week. So all of that information is important because when we study rhombi, the first characteristic is that they have all the same characteristics of a parallelogram. So their opposite sides are parallel to one another. Opposite angles are congruent to one another. Consecutive angles are supplementary. Diagonals still bisect one another. So they share all of the same characteristics, except they have a few more qualities that we need to talk about. So not only are opposite sides equal, but all their sides are equal to each other. So every single side is congruent. This fits into a parallelogram because parallelograms say opposite sides are congruent, which they still are. We're just a little bit more specific when we say they're all congruent. Diagonals still bisect one another, but this time they bisect at perpendicular angles. So I'm going to draw a 90-degree angle in here. And their diagonals bisect the angles. So that means every single angle is cut in half. So this side of the angle is congruent to this side of the angle. It's still congruent to the opposite side. So the total angle is congruent to one another. So this entire angle is congruent, okay? But it's also bisected. Same with the other pair of angles. They are bisected, and the whole entire angle is equal to the opposite side. Another great slide to take a picture of. So we're going to use this information to solve different types of problems. So this figure is a rhombus. They want us to find all the labeled angles. So we need to use the prior slide and the information we got about angles. We got that the diagonals bisected at 90 degrees. We got that the angles are bisected of one another. So I'm going to start then with angle number 1. So angle number 1 is the intersection of the diagonals, which means that angle number 1 is a 90-degree angle because diagonals intersect at a, or their diagonals intersection are perpendicular lines, which means that's 90 degrees. The second angle that I can find is angle number 2, because recall, opposite sides are parallel, so a diagonal serves as a transversal. And now I have alternate interior angles, and we know that alternate interior angles are congruent, so angle 2 is also 61 degrees. What we just learned is that the diagonals bisect this entire angle. So it cuts angle A into 2 equal parts. So if angle 2 is 61 degrees, angle 3 is also 61 degrees. And then finally, to find angle 4, if we focus in on this shape being a triangle, we know that a triangle is 180 degrees. So I know that angle 1 is 90. Angle 3 is 61. So if I add those two angles together, I have 151. So to find what's left over for angle 4, I subtract 151 from 180 to get 29 degrees. So a lot of concepts wrapped into one problem. We have our diagonals crossing at a perpendicular angle, alternate interior angles. We have the diagonals bisect on a rhombus, and then we have our interior sum of a triangle. So you're going to try below. The figure is a rhombus. Find the measure of the numbered angles. So I'm just going to give you a hint. We know that the diagonals bisect the angle, so that means that angle 1 is going to be congruent to angle 2. Angle 3 is going to be congruent to angle 4. We also need to use the fact that we have 2 sets of alternate interior angles. So that means that angle 1 is going to be congruent to 4 and angle 2 is going to be congruent to 3. So if 1's congruent to 2, and 2 is congruent to 3, then we can use the transitive property to say, well, then 1 must be congruent to 3 as well. So what conclusion can we draw? All of these angles are going to be congruent. They're going to be the same exact measure. The second quadrilateral that we're going to focus on is a rectangle. Once again, a rectangle holds all the same characteristics of a parallelogram. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect. So those 5 characteristics keep popping up over and over and over and over again. However, now we're going to add a few specific characteristics for rectangles. For rectangles, all angles are right angles, which still fits our characteristics of a parallelogram. Opposite angles are still congruent, and consecutive angles still add up to 180 degrees because 90 plus 90 is 180. And another very specific characteristic is that the diagonals are congruent lengths. So if I labeled this as rectangle ABCD, diagonal A to C, that entire length, is going to be equal to diagonal BD. Since they're all congruent measures, that means every single one of these diagonal midpoints, so from D to M, from M to B, from M to C, from M to A, all those measures are congruent as well. So we're going to use that to solve some problems. So we are building a frame, and the window will be installed in the opening in this diagram. The opening must be a rectangle. So we are given the measurements of these opposite sides of 33 and 44. Is that enough information to conclude that this is a rectangle? Now, it physically appears like it's rectangle, but you don't know the exact degree of the measures of the angles or the diagonals. All we're given as part A is that opposite sides are equal. That is not enough information to conclude that it is a rectangle. The only conclusion that we can make right now is that it's a parallelogram, because a parallelogram characteristic is that opposite sides are congruent. Part B, they give us the information about the diagonals. So they tell us that one diagonal is 54.8 inches and the second diagonal is 55.3 inches. Is this enough information? Yes. We can say that this is not a rectangle because of that characteristic that we just learned, that diagonals are congruent. So since 54.8 is not equal to 55.3, this is not a rectangle. Before you try your example, I'm going to go back to this prior slide to give you an opportunity to take a picture of a rectangle with its characteristics so that you can use this for your notes. So you're going to try similar example with the window, except now they give you one more piece of information. They tell you that one of the angles is 90 degrees. Can you conclude now that this is a rectangle? The second characteristic that we learned about rectangles are that diagonals are congruent. So they are giving us that Q to S, so that length right there is 5x minus 31. And then they're telling us that R to T, so this diagonal, is 2x plus 11. They want us to find the lengths of the diagonal. Well, we know from a rectangle that diagonals are congruent. Therefore, we're going to set our two expressions equal to each other. So I have 5x minus 31 is equal to 2x plus 11. We're going to solve algebraically. So I subtract my 2x from both sides, so I get my x's together. I add 31 to both sides. So I have 3x is equal to 42. And then I'm going to divide each side by 3. And 42 divided by 3 is 14. So x's value is 14. They didn't ask for x though, they asked for the length of the diagonals. So since the lengths are congruent, I only need to choose one expression to plug it into, and it doesn't really matter which one you plug it into, you'll get the same answer. So I'm going to plug it into the top one. 2 times 14 plus 11. 2 times 14 is 28. 28 plus 11 is 39. Our final quadrilateral is a square. So a square contains all characteristics of a parallelogram, a rhombus, and a rectangle. So starting with the parallelogram, opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles equal 180 degrees, and the diagonals bisect. We can get more specific, though, as we talk about now a rhombus. So for a rhombus, all sides are congruent, not just opposite sides. When our diagonals bisect, they bisect at a 90-degree angle, and they also bisect every single angle. There's even more characteristics now when we talk about a rectangle. So we're going to include the fact that every single angle is 90 degrees and that the diagonal lengths are congruent, which means every single piece and part to our midpoint is also congruent. So a square has a lot of characteristics, and it's all the characteristics of a parallelogram, rhombus, and rectangle. I'll give you a moment to take a picture.